Okay, we're going to take a quick look here at a possible issue you may run into when performing firmware migration from enterprise to MPP. So if you're going from, example, CUCM, the phones are running enterprise firmware, you're migrating to MPP firmware, also known as 3PCC firmware for Webex calling, and you're running into an issue where you're doing all the correct steps, however the phone does not want to migrate. So one of the potential items you may run across is a MTU setting on the WAN interface of your router. So in this case, we're going to keep the examples as simple as possible, and we have a simple router here. The LAN site is F01, WAN is F0/0, and you'll notice that we have an MTU of 1380, and we're going to go ahead and take a look at the pattern that you would see in a Wireshark capture. So this first example I'm showing is a capture I took on the WAN side of the router, and you'll kind of notice this effect where the phone itself is 192.168.23. The actual firmware migration server in the Cisco Cloud Upgrader is 3.14.11.49. So they kind of start their normal handshake, and then the phone will start the onboarding process or attempt to start the onboarding process. And what you'll see is this pattern here where the actual Cloud Upgrader server will attempt to send packets to the actual phone. And again, keep in mind this is captured on the WAN side of the router. And you'll notice it's set at 1434. And you'll start getting these items here listed that it's retransmitting, TCP retransmission, 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 and it'll basically go ahead and give up for a period. So you can go through the actual Wireshark capture, and what I'm using to filter this out, because there could be a lot of information, is one, when I actually captured this on the WAN interface of the router, I did use a filter for the host IP address, the WAN interface of the actual router itself. And then when I'm inside the actual PCAP, I'm doing a TCP.stream equal 4. So I kind of preemptively went through the different streams and identified the ones I'm interested in, which is really my phone, 192.168.123. going to the 3.14.11.49. But what you're going to notice as I go through these pages is the pattern kind of remains the same. The phone starts talking with a Cloud Upgrader server, and then a Cloud Upgrader server tries to respond with a larger 1434. And this is kind of where the problems run into right here. And those larger packets can't get to the phone. So again, we're taking this capture right now on the WAN side of the router. But as we kind of go through these different portions of the PCAP, and all I'm doing is I'm just incrementing the last digit here. So TCP.stream equal 20. This is just to make it easier to view the actual PCAP, because normally there'll be a lot of information, a lot of other noise. And you want to filter it down to something that is consumable in kind of what I'm presenting here. But again, you'll kind of notice that the phone will attempt to communicate to the Cloud Upgrader server, and initially things will kind of look like they're going good here, and then the actual Cloud Upgrader server is going to try to send packets that are larger size 1434, and that's kind of where we'll run into problems. We're going to go ahead and take a look at in a moment here about LAN capture. But what I did here is I went ahead and I sorted all the packets based upon the length field. So in Wireshark, it's kind of like using Excel and being able to do different type of sorting. If you click on this length field, it will actually sort all the packets. So in this case, we're going from the largest to the smallest packet. But you'll notice the same pattern we saw a few moments ago, where the actual Cloud Upgrader server 3.14.11.49 is attempting to send larger packets to the phone 192.168.1.23, but those are kind of failing to get to the phone. So it kind of repeats that. I did this capture probably for about 8 to 10 minutes, not super long, but you see in that period of time there's multiple attempts. Let's now look at the LAN side. What does the LAN side look like? Well, if we sort it again, so this is the LAN side packet capture. If we sort it based upon the length, there's no packet size that's larger than 522. So this is really solid evidence there's something happening to the packets at the router level. They're not getting through the larger packets. In this case, one has already looked at, are there any firewall rules that are interfering? No. Is there anything other special? Well, the only thing really is the MTU setting. That's, in this case, the root cause of this issue. So how do we fix this? So the only adjustment we really need to make, we need to set the MTU to 1500. The reason I've illustrated this in this way is by default the router for the fast Ethernet ports is already MTU 1500. So when you go and you configure this, and I'll show this in a few moments, in the interface fast Ethernet 0/0, and you set it to MTU 1500 and do a show run config, nothing shows up as far as MTU. The reason is it is by default 1500. So this right here would actually fix the issue. We'll take a look at it. There is a word of caution here. You would want to find out why was the router in this case set to a lower MTU. There could be other technology that's being used. So by you changing this, you can cause outages and issues. So one is you would want to investigate why it's not being used. And is this adjustment you can make? And number two, you want to make sure physically somebody is at the router. So if you do make the adjustment and you lose connectivity, it can be reverted back. Also, you want to make a backup configurations of the router the way it was working before any changes, get all the needed approvals, maintenance window, etc., etc. So even though what I'm showing here is kind of simple, there is a level of risk involved. Okay, so in this PCAP, this is going to be a working example, and we're taking this from the WAN side, and we're sorting it again on the length. So you're going to see a majority of these packets are 1434. And we'll just kind of go down the PCAP here. So if we look at the length here, some of these packets are even larger, 2802. So these are kind of on the larger side. So if we keep on going down, again, 2802, continuation, 2802. But at this stage, you can tell that there's a lot of information flowing from the cloud upgrader server 3.14.211.49 to the actual phone, 192.168.50.15. And what is happening during the onboarding / firmware migration phase is there's fairly good sized binaries that need to be downloaded from the cloud upgrader to the phone. So basically what happens is the first phase is the phone needs to be at least at 14.1 enterprise firmware. Most cases folks will use the cloud upgrader so they don't have to put the firmware in their CUCM, although they could put on the CUCM local TFTP. But in any case, in this example, it is coming from the cloud upgrader, so those binaries will take time to download. And generally, the whole process from start to finish, because the phone will go through a couple phases, so making sure enterprise 14.1 generally that'll be anywhere from 3 to 5 minutes for the binaries to download, assuming there's no bandwidth limitation. It takes about a minute and a half for the phone to reboot. Then once the phone is on 14.1 or higher enterprise firmware, then it's ready to go and download the MPP firmware. The MPP firmware typically, it used to be 11.3.7. I believe recently that's been updated to 12.03. But in any case, I'll download that firmware and then it'll reboot again. And then when it does a handshake with Webex calling for the onboarding, there'll be some additional configs that's going to download and it'll reboot. So generally you'll see probably around 3 reboots, and might be even 4 reboots that occur. And the whole process from start to finish, I would say, is about 15 minutes, assuming there's no bandwidth limitations. If you're doing a fleet of phones, then obviously those fleet of phones will be contending for available bandwidth, so your times of what I'm mentioning of 15 minutes definitely will go up, half hour or longer. And I recommend doing smaller batches of phone, because you don't want to do a large batch of phones and then realize you have an issue. Now you have to troubleshoot a bunch of phones. And then this is taken the LAN site, so we are getting these larger packets that are getting to the actual phone itself. So we'll just kind of go down this packet capture from the LAN side. So this will be here the distribution of packet sizes in a working configuration. So this is taken again on the LAN site, and if we look at the percentage column, we'll notice a majority of the packets are going to be in a range of 1280 up to 2559 packet size length. And then if we look at the next example here, which is going to be in a WAN site, again we kind of see the same pattern, which would be expected, of 1280 to 2559 for packet lengths. And then the next one here is when it's not working. So in this example, it is when it's not working. And what we're going to notice, and this is taken on the WAN site, so this is before the packet has to traverse the actual router toward the LAN. And you'll notice that we only have about 11%, and those are those attempts of those larger packets to get to the LAN site, but they never get to the LAN site because the MTU is set to a lower number. But once we go ahead and take a look at the LAN side, you'll notice the packets, none of the packets actually in this example exceed 1639 packet size. So before where we're seeing activity at times quite a bit activity at 1280 to 2559, there's nothing there. The reason I show these different screens in Wireshark is to give you some tools, so when you're analyzing, you're able to use a couple different tools to get evidence to understand what might be happening. I will show a demo in a few moments with equipment so you can actually see what it looks like, because there's a couple other techniques or tools you can use. And then the one other thing, which I'm not going to really focus in on this video, but there are other videos and a lot of other documentation out there, is if you have a more advanced wide area network, SD-WAN, etc., other than the MTU adjustment that I'm covering in this video, the other adjustment you may come across that could cause you some headaches is this IP TCP adjust MSS. So this is the Transmission Control Protocol, TCP, maximum segment size adjustment. Feature enables the configuration of the maximum segment size for the transient packets that traverse a router, specifically TCP segments with a sync bit set. So the best thing to do is take a look at the documentation for the respective routing equipment manufacturer using regarding the recommendations and best practices when it comes to the TCP MSS adjustments. Okay, we're going to go ahead and take a look at the phone itself. So I've set the Cloud Upgrader server address TFTP server number 13.14.211.49. And generally, what you would expect to see is somewhere around a 3, 4, 5 minute time mark. You would get a message that the phone is ready to upgrade its firmware, and there'll be a countdown timer, 15, 14, all the way to 0, and the phone will reboot. In this case, we will not see that occur because of the MTU setting we have on the WAN interface. And as far as how long this may take when you're testing, if there's no bandwidth limitations, 3 to 5 minutes. It may take longer if there's bandwidth. So another easy test to check if we're running into the MTU issue is you can do a ping over to the binaries.webex.com. But then you want to force the actual payload size. We're going to force it to 1500 using a dash L 1500. And if you notice now, those pings cannot go to that site and come back to us. And what's happening is those pings need to be fragmented when they hit the router WAN interface, and that's where the pings are being dropped right now. And there's one other test we can do, is try going to a web page that is larger in size. So this page I'm going to right now, the Webex port reference information document, is a fairly large document. And if you notice, I've clicked on it, the browser is trying to get there, but it's never going to be able to reach there because we're exceeding the amount of data that's embedded in this web page is exceeding what the router can handle across the WAN interface with an MTU limitation. It won't allow it to be fragmented. So these are very two simple tests you can perform if you're running into this type of issue with a firmware migration, where with these two tests we're not even having to do a Wireshark capture. Okay, so we're going to go into the router right now. And if you notice the fast Ethernet 0/0 interface, we have the MTU of 1380. So that is the root of our issue right now. We need to go ahead and adjust that to an MTU of 1500. So we're going to go into config T mode, int fast Ethernet 0/0, and then we're going to give it the MTU of 1500. We're going to go and back out, and we're going to write this to memory. And we're going to do a show run just to do a visual inspection. Okay, if you notice fast Ethernet 0/0, it does not actually show the MTU of 1500. The reason being that is the default setting. So this is normal what we see right now. So I've actually powered cycled the phone a moment ago. Just so we're not waiting here an extended period of time, we're going to go into our Ethernet setup, IPv4 setup, and we're going to inspect to make sure the TFTP, the alternate TFTP is turned on. It is. And it has that IP address of 3.14.211.49. What happens sometimes is when a phone is attempting to do the firmware migration and it fails and it fails and it fails X amount of times, it may get stuck in a loop. So what I like to do is, if I know the phone's failed X amount of times, instead of waiting and not knowing if it's going to do something or not, after I've fixed whatever is the issue, like in this case was the MTU size on the router, WAN interface, it's always easiest to go either do a shutdown, no shutdown on a switch port that the phone is plugged into that's getting PoE, or just power cycle the phone. Okay, so it's ready to upgrade, and it's doing the 15-second countdown timer. So it is enterprise firmware right now, 14.1/1, and it's going to go in and upgrade or migrate to the MPP firmware. The reboot of phone is about a minute and a half. Cut down some of the sections in the videos is not super long. So when you go ahead and do it, be aware it may take a little bit longer than what I'm showing you right now. Again, I've cut down the reboot section because that's about a minute and a half. And what it's doing right now is a handshake as it's going through the onboarding phase. So initially when a phone first boots up with MPP firmware, it does a handshake with a server in the cloud called the EDOS server. And that's where a basic profile will be waiting for the phone that's generated from Webex Control Lab when you ran the firmware migration task tool for this phone. And generally, two things the phone is going to get from the firmware migration, assuming you selected add the device and also generate a license for the phone within the firmware migration task tool. The device will provide, so this, you may see some messages, they'll come up temporarily like you just saw there. That's going to go away because from the firmware migration task tool, the phone is and was able to fetch the needed license. Also the configuration profile, So the phone is registered to Webex calling. We have a PSTN number. I've blurred out a portion of it because of obvious reasons. And then I have my extension 205. So from a phone standpoint, we've solved our problem. Let's go back and let's do the ping test again. So remember before this was not working, and now it works with the dash L 1500, the payload of 1500 byte size. And the only adjustment we made was really the MTU on the router WAN interface. So let's take a look at this website. Again, this website was not working before, and now this website works. So these are two basic steps. The ping, by increasing the payload size to 1500, you can check and see if that goes through. And then going to this port Webex calling port usage document, it's quite a large document. And this would also test if there's something going on where the router is not allowing fragmentation to occur. Also, I should mention, we're focusing on MTU configuration, the WAN interface of the router in this video. But also, more often than not, when you do run into firmware migration issues, they tend to be related to potentially security settings, router, firewall, or other devices. This page I'm showing right here is an essential page you want to definitely look at if you're running into any issues and it's not related to MTU. Thank you for watching this video. Hopefully this helps you with the firmware migration process. Thank you.